All right, well, hello everyone. Thank you for joining today's webinar. My name is Pete Murphy from HashiCorp, and I'll be moderating today's webinar titled Tooling for the Modern ISV with Microsoft and HashiCorp, which will be presented today by David Wright, Channel Solutions Engineer from HashiCorp, and Michael Friedrich, Cloud Solution Architect ISV at Microsoft. So today, Dave and Michael are going to talk about some of the typical challenges you could face when building SaaS applications in the cloud and how to solve those problems using modern tools designed for the cloud. So I also want to note that this session is being recorded, and the recording will be made available after post-processing. Usually takes a couple of days, but I'll send an email out to everyone who registered with a link to the recording. So today's webinar will run for about 45 minutes. And we'll dedicate 15 minutes at the end for an open Q&A. So do please submit your questions throughout the session in the Q&A tab at the bottom of your screen there, and we'll get to your questions at the end of the session. So with that, let's go ahead and get started. Over to you, Michael.
Thank you very much, Peter. Can you hear me okay?
Yep, loud and clear.
Fantastic. Could we just change the slide, please, David?
Sure.
Cool, just to slide 3, please.
There you go.
Perfect, thank you very much. Cool, so today we're going to be talking about SaaS marketplace opportunity first. So SaaS represents an opportunity for independent software vendors to fundamentally transform their business to deliver greater value and sell software to a broader range of customers and streamline internal processes. So a bit of research was done a few years ago, and the opportunity or forecasted size of the SaaS marketplace by 2020, which is this year, is estimated to be around 99.7 billion, which obviously is quite sizable. So with that in mind, what are the key benefits of moving to SaaS? So there's 4 key benefits that research showed. The first one is unlock new customer segments. So with SaaS, you can sell to a broader customer base, adding customer segments that were previously unprofitable due to the lower cost to serve and reduced technical requirements enabled by operating SaaS on the public cloud. Adopting a SaaS model that runs in the public cloud also eliminates many barriers to geographic expansion. Cool. And the second key benefit we have is reduced complexity and lower customer TCO. So one of the single biggest benefits of shifting to SaaS delivery is that customer hardware and infrastructure can be moved into a single unified infrastructure for application development, which you control. With SaaS, you can free your customers from many of these costs by taking on the responsibility of hosting software through public cloud. A unified environment allows your development teams to focus more on high-value product feature development and less on maintaining systems infrastructure. Also, integrating new cloud services. The integration of value-added cloud services allows you to improve your service offering by providing capabilities that previously would have been time and costly to develop yourself. Specifically, services like Azure Cognitive Services brings AI within the reach of every developer without requiring machine learning expertise. All it takes is an API call to embed the ability to hear, see, speak, search, and understand into your application. Also, leveraging aggregated data. Cloud ecosystems facilitate easier collection of customer usage data, providing you with more detailed insights into customer needs and pain points. Insights generated through application data enable you to focus on product development efforts and the features most important to your customers, and to deliver those features faster. Next slide, please, David. Cool. So common deployment models for ISVs. So when designing a SaaS application, you must carefully choose the model that best fits the needs of your application, business goals, and customer requirements. This line graph here outlines a general progression of models, with each level providing greater access to the full benefits of SaaS. Cool. So the 4 models that we have here are hybrid, which is normally combining on-prem and cloud models, typically for legacy applications. The second model we have is single tenancy. So that's where you're deploying a dedicated instance of your app for each customer. The third model here is minimal multi-tenancy. So if you have an end-styled architecture for your application, typically you might have a multi-tenanted front end, a multi-tenanted API layer, and then a dedicated database for each of your customers, is how I like to think of that. And finally, the dream state here is mature multi-tenancy, whereas you have multi-tenancy through each layer of your application. But it's not one size fits all. If you operate in a highly regulated environment, then the mature multi-tenancy and minimum multi-tenancy models might be off the table for you due to customer requirements around tenant isolation, for instance. Or conversely, you might operate in a consumer market where reducing complexity and lowering customer price is paramount, then a single tenancy model might be off the table. Or if your company has started in the cloud, then you're probably not going to go towards the hybrid model, because you can just stay in the cloud where you've built. Cool, thank you, David. Next slide. Perfect. So it's not all rosy. There are some challenges when you pick these different models. So the below table kind of summarizes the difference between deployment models across different challenges. So firstly, if you look at scale, you can see that single tenancy models tend to have a medium level of scalability, and multi-tenancy models tend to have the highest level of scalability. Now with tenant isolation, we can see that the single tenancy gives us a higher level of isolation because you're deploying a separate instance of your app per tenant, and the multi-tenancy model gives us the least amount of isolation. Now, cost per tenant. We tend to see that single tenancy have a higher cost per tenant because you're deploying a dedicated instance per customer, and multi-tenancy tends to have the lowest cost per tenant because all your tenants are sharing the same infrastructure. Now, development complexity is a little bit tricky. We tend to see single tenancy have a lower levels of development complexity and multi-tenancy higher. But if you have a kind of a bit of a deeper dive into that, if you have customized versions of your code in the single tenancy model per tenant, this can quickly become very complex as you scale, as you're going to have different branches of your code for different customers with customizations. It can get very tricky and very complex. And lastly, if we look at operational complexity. With the single tenancy model, like we saw with development complexity, with a small amount of tenants, this becomes less complex. But when you have a large amount of tenants, it can become crazy complex really quickly unless you have great tooling and processes. And conversely, with multi-tenancy, it's less complex to manage the system as a whole. But if you want to start managing individual tenants by themselves, it becomes quite complex. Cool. Next slide, please, David. Cool. So what can we do about it? So for me, automation is key to unlocking complexity and scale. So some challenges in the previous slide are somewhat out of our control. For instance, if you operate in a highly regulated industry, you might have to have isolated tenants, which can then affect your tenant isolation requirements and also potentially your cost per tenant. But one of the things that we can always normally control is how we scale and reduce complexity in our SaaS product. So where do we start? So for me, one of the best places to start is infrastructure as code. So infrastructure code enables you to manage infrastructure, i.e. networks, virtual machines, load balancers, in a descriptive model using the same versioning processes as a DevOps team would do for their application source control. Now, teams who implement infrastructure as code can deliver stable environments rapidly and at scale. Teams avoid manual configuration of environments and enforce consistency by representing the desired state of their environments via code. Infrastructure deployments with infrastructure as code are repeatable and can work together with a unified set of practices and tools to deliver applications and their supporting infrastructure rapidly, reliably, and at scale. So that's my bit on that. So over to you, David.
Thank you, Michael. So Michael talked about infrastructure as code, talked about some of the challenges around multi-tenancy, and talked about some of those challenges for managing customers across those domains. So what we're going to do is, I thought I'd start this by actually just diving into having a look at what some of these challenges, or how we could actually address some of these challenges straight off the bat. And so what we're talking about is actually this, for those that aren't aware, is Terraform code. So in this Terraform top sheet, what we're actually doing is deploying using a randomly generated name. We're defining a prefix at the start of it, and we're deploying modules that actually deploy Kubernetes managed clusters across, in this case, all three of the cloud providers, or this could be across a multi-region environment. So taking Michael's example, where we start to look at how we can manage those multi-tenanted environments, or looking at how we actually deploy into a region, and looking at how you manage and tool for all of those separate segments, then you can use these kind of modules, and we can use the repeatability of Terraform code to actually look at and deploy against a customer. So this could be, a customer prefix that you'll determine, and then you create some sort of randomized name. In this case, I've used pet names because it was funny, but there is other random IDs that you can do, or other elements. And of course, when we look at the module, obviously what this does is, a module allows us to push individual components down to that code set. So in this case, we're taking our random name and shoving it down to our cluster. So if we actually look at what that cluster code looks like, because obviously there's a lot more going on under the hood than just that, we can start to see here that we've got our breakdown of what we're actually starting to deploy. And so, AKS, we'll go to that one. We can see here where we have our provider. So a provider is our mechanism that actually allows us to talk to the APIs and allows us to actually understand what needs to be called. Then we have our defined resources. So those resources are elements that allow us to actually interoperate and set components. So here we're setting some tag environments. And again, these could be pulling in environment variables to actually make them unique. So now in that multi-tenanted environment, as you go through, you can uniquely and programmatically apply tagging and the right tagging so that you can track resources against customer. It also allows you to actually tie spend, because obviously trying to figure out in either a single tenancy or even in a multi-tenancy, if you have particular customers that are heavy users and looking to find out why that particular use case is, or looking to find out how to tune your model, this being able to enforce tagging and that trackability is obviously going to become really important. And another thing that I wanted to show here is we're actually inputting the service principals as variables. So obviously, once you start having repeatable code and using the infrastructure as code, as Michael mentioned, how do you pull that in from a pipeline? How do you test that? How do you put that into repos? And obviously, all of those things then create a security risk. And so some of the things that I'll be talking about is obviously meeting some of those other challenges. So with Terraform Enterprise, we actually leverage our vault secrets management. And what that allows us to do is actually then obfuscate this and allow it to be obfuscated and kept secretly and securely, so that you can share the code, you can store the code around, you can use the code in different places without the risk of credentials being leaked. So just from an understanding, and so people can understand some of the concepts we'll kind of go into in a little bit, I just wanted to go through a couple of basic components. So if we actually went to run or perform the first stage of deploying this code, we would do a plan. And what Terraform is doing here is it's actually going and starting to pull in talk to the API, pull in all the resources and actually understand and start to plan that declarative model. So what are we saying our end state will look like? And so it's going through and making sure that we can talk to all of those components, making sure that it understands that the code is verified. And one of the really good things about Terraform is it has a very human readable syntax. And then it will tell you what it's going to do. So in this case, it's saying we're going to add 22 resources, because obviously there's a lot of things happening across deploying Kubernetes across all three clouds. And you can see that these are all of the elements that it's going to walk through and actually deploy. And so you can see in some of these, it actually knows what the address is. So that's stuff that we stipulated. And you can see in some cases, it doesn't know. And so in the plan, because it obviously isn't going to know some of the cluster IDs or security IDs, it puts in the known after apply. So once we then actually go to the next stage, so we're happy with what this is going to do, we can then actually apply a plan. But the other thing that's interesting is that you can actually do a targeted apply. So you can actually do it against a particular module. So in this case, if we go to this is actually saying that we're going to deploy a specific component of that top sheet. So we're going to deploy a particular module, and now you can see we're only deploying 3 objects. And so why is that? Why does that make it helpful or important? Well, as Michael talked about and said around how do you start to manage those customers in different environments, if you start using infrastructure as code as your mechanism, Terraform allows you to then actually do updates, changes, moves, and all of that infrastructure is managed as code and updated as code. So now you have a programmatic way to control your users. And so with that, I just want to dive into some of these concepts in a bit deeper way. So firstly, obviously, we're looking at one of the big differences between cloud native elements and how Terraform approaches its approach is obviously Terraform is available across any cloud, hybrid or on-premise. So meeting those multi or single tenanted challenges becomes a lot easier because you can use it outside of the cloud structure. But also it focuses on a workflow, and a workflow for us is the ability to break down the individual elements that you're going to apply and push that into different deployments. So a workflow can be an overall customer onboarding. It could be a new feature that's been applied to a particular component, but it's an actual end business outcome. And then within that, Terraform uses this concept of workspaces, and workspaces then actually do those individual runs. And so those individual runs allow you to then build elements to create that overarching workflow. And one of the interesting things is you can see here is we can also, we talked about in that short demo about being able to plan and then apply. Another mechanism with Terraform Enterprise is in the middle here, you can actually inject security policies. So one of the functions that we have as Terraform Enterprise is Sentinel, which is our policy as code. So we've taken the concept of infrastructure as code and applied that to how to actually create some security standards, governance and compliance. So being able to put in controls, apply what instance sizes, what regions, who can deploy what, and also being able to do baselining security components. So we have created a repo recently of foundational policies based on the Center of Internet Security that have baseline policies that will allow you to check your infrastructure before it's stood up. So what this is doing is allowing you to actually put policy as code in place. That means that as you define your infrastructure, you're actually know that security is baked into it, rather than having to stand up security and then retro scan or go and retrofit or actually doing the scanning behind it. So it's another tool to give you this ability to create secure environments, standardized practices, and a lot of time to actually not have to get approvals, because you've built these structures into a mechanism that you're confident in. You can then just create that into your pipeline, and then you have faith in your pipeline. So it becomes all automated. So within that structure, how do you actually then start to think about what you need and what to build? So in that demo, we saw that there were 3 modules, and those modules were broken down around deploying Kubernetes clusters in a particular environment. What you can do is you can extrapolate that out. So in your single tenant environment, you could pull in modules that build your build the VPC, set up your VNets, set up any of the resources, and build out those individual structures. And you can use those or build modules that then become repeatable pieces of code. So using that concept of, don't repeat yourself, so the whole dry methodology, and looking at how each of those modules provide a function. Or it could be that once you've created those modules and baseline, now you start to actually think about how each of those modules become a function. So is that a new function that you can add on top of your application? So as Michael talked about, being able to engage your customer faster, being able to get more features out. The SaaS world is all about the user experience. When you look at the high street banks these days, high street banks used to be who could have the most amount of shop fronts and customer experience in getting people through the door, and branches. Now the battle is all on your mobile phone. Who's got the best app? What's the best app with those features? And that's not, that pivot has only been in the last 5 to 10 years, or five years really. And so when you look at how you can try and, as an ISV, and pushing as that kind of productization, being able to create these repeatable patterns where you build it once, test it, build confidence in it, and put it into your pipeline, and then you can just use it, means that you save a whole amount of time. So again, that ability to adopt faster, reuse, and not have to go back and reinvent the wheel. So there are 2 ways to consume modules, and this is, there's the private, there's a public module registry. So this is where HashiCorp and Microsoft, for example, work really well together, and we do co-publishing of resources and modules that provide particular functions. So for example, standing up AKS, or you know, even deploying VMs and resources or databases, SQL components. We work together and we create joint modules that allow you to consume that functionality easily without having to actually think about creating all of that construct. We've also been working closely together to create, you know, patterns and repeatable patterns like landing zones to be able to consume and drive those modules. And if you look at the cloud adoption framework, there is a Terraform section within that to actually drive those patterns, which are, again, modularized. But once you have a module, obviously, it may not necessarily suit your use case, or you want to have different versions of it because one version is for a single tenanted, another for a multi-tenanted, or you tweak some particular password structures, you tune the database in a particular way, you want Kubernetes to have a particular version that you're running. So how do you manage that? So what you can do with Terraform Enterprise is you pull that module in via your version control system, and now you have a private registry that you can attune. You can make sure it meets your security standards, and then you can consume that as you would do a standard module, should I say. And so that allows you to now have that flexibility. And again, it's that next level up for engaging with Terraform Enterprise that gives you that ability to consume and really drive that repeatable structure that you need for scaling for large-scale customers. And so I talked about workspaces a little bit, and this kind of gives you that idea around how leveraging those individual workspaces and runs, you can create those micro infrastructures to actually create an output. So I pull in, or I have different teams writing different forms of code that sit as specific modules that go through a testing structure. They all pass through the testing. Once they've passed testing, they go into a pipeline. And then once you can have a commit, obviously the pipeline is pushed out to either update the application, or you could actually use it as a trigger mechanism for customer onboarding experience. So as a customer comes in and says, I'm registering, that could actually be a trigger via a webhook to kick off a build process that then deploys and automates your customer onboarding experience. So again, how do I get customers onto the platform faster? How do I push changes into the environment faster? How do I get and increase my customer experience and looking to improve that experience using programmatic control? And again, you know, all of this goes into the fact that Terraform is infrastructure as code. It is declaring the state that you want. And so because it is code, you can treat it and should treat it the same way as you would do your actual application. How do you test that? As you create a rigorous pipeline standard that you have confidence in. And so where you should be is that when you kick off a build, you walk away and you know you have confidence that it will build and declares its end state. And so by having that level of confidence, how and what does these things give you? And so, you know, Michael touched on a little bit when, you know, the holy grail was that whole multi-tenanted element across a mature multi-tenant environment. You know, from a simplicity perspective, even being able to push and build a pattern into multiple regions, you know, one of the big things that we see, or I see quite regularly with SaaS providers, is that it's built out of one particular location. So obviously they have their founding location, and a lot of times that is the primary and only element that you have it. So if you want to consume it and you have any form of data sovereignty, or even just want to have some form of local control, or even performance, you know, some application performance, they don't have that ability to push to multi-region. And so being able to have obviously a repeatable set of code base and patterns that you can then push to anywhere just by changing what the region is and where you build, obviously that gives you a greater ability to expand. So as you acquire customers, as you look at what that customer base and growing customers in particular regions, so your expansion model becomes just a small programmatic change that allows you to really expand and follow on and meet your customers' needs. So the other thing that is important, and we've talked about it a little bit, is that when you run that apply, when you run it, you have that declarative component, which is the end state. And so one of the things that with Terraform Enterprise is that we manage that end state. So when it gets to the end of a run, it creates a state file. And that state file is what we use to actually know the state of your infrastructure. And so managing that state file becomes really important and really, really an important mechanism to control. So as we get into Terraform Enterprise and having those state files known within it, it also means that you can then pull and cross-populate across from those files. So if you run your network build, for example, and you need that VPC ID, you can pull that out and run it into another element. So how you start leveraging those known states and cross-populating your modules or your code runs, how do you get information across that structure and share? But also how you then scale and share and manage that system across your dev teams. So as your organization grows, so you have more and more people that will be managing the infrastructure and growing and touching it, how do you manage those states? How do you manage and have a single point of control? And Terraform Enterprise becomes that single point of control for managing those end states. And so just shifting gears a little bit, we've talked about now provisioning. So we now have built our infrastructure. We've now got our infrastructure in place. One of the other interesting challenges is obviously how do you then start to manage users and manage some of the security concerns around that. And so Vault is our security secrets management platform. It has a couple of other features that we talk about that are interesting in this scenario as well. But fundamentally, the important thing is it's an API-driven front end. So particularly for an ISV built on the cloud or predominantly building in the cloud that needs a dependable, repeatable API that can give them access to their secrets, this is a mechanism that really allows you to do that. The other advantage of it, of course, is the fact that you can build this anywhere. So if you have regulatory constraints that says that you need to have some data sovereignty or on-premise component, you can build it there. If you want to be able to have different secrets across different cloud platforms, you can build multiple elements that then create a master-slave element or clustering. You can build this so that you can centralize and have different structures, but all of it is being driven from a single repeatable API. So this also means that your dev teams have a consistent API that they can write against and actually allow them to develop faster. And this is also true for some of the other components. So one of the other features that we have is a feature called dynamic secrets, and we'll take a look at this a bit later. But a dynamic secret is, instead of a key value pair with a standard secret element or secret, a secret, there you go. What you have is a dynamic secret. And so what that is it allows for the ability to create a username and password dynamically. And so why would I want to do that? Well, when you think about those scenarios that Michael talked about and the different scenarios around how do I get the best out of my database, how do I multi-tenant that, how can I carve that up? Obviously, you don't want to create single password structures for that. You don't want to share those. You want to limit the blast radius and create, as tighter security model as possible. And if something does get compromised, you don't want that to then have also compromised other users. I mean, that's the worst case scenario. And we see many ISVs that have done this badly being really, roasted for it. And so having the ability to create a dynamic secret, so this dynamic username and password particularly with database credentials, and that's the example that we'll look at a bit later, you can see that as a user starts to interact, Vault can actually issue a unique username and password for a specific period of time. So you set a time to live around it, and now you have a specific username and password for access to a specific database or segment of a database, and you create a time to live around that for that application run. Now that application run could obviously be for the day, it could be for a week, it depends how heavy a usage of the application it is, or you could actually shrink that down for almost a one-time set of passwords, depending on your security needs and the load that puts on the API calls. But you're starting to see where Vault can now actually allow for that separation of duties, and also allowing for you to provide a lower attack surface overall for your tenants and for your application. Now, there are a lot of ISVs that we've worked with that have integrated and start to use Vault. So Adobe is there's been a keynote for us, and they're a great keynote. They've spoken about how they use Vault to handle millions and millions of transactions per second across their authentication and financial sectors. They are also a heavy user of automation as code. So you can see that although Terraform and Vault are relatively new, we've been around since 2012. There are a lot of large enterprises that have now realized that those challenges that we solve for are common across their environment and looking for ways to actually be able to do that. And Vault, with that single repeatable API, was built as a machine-to-machine predominant application. So it's built to handle that level of scale. It's built to level that handle of speed. And so those are some of the real benefits by leveraging those Vault components. And Vault, there's a Vault Enterprise as well. Vault Enterprise also allows you to then start looking at how you can do separation through namespaces. So now you can carve up internally across particular customers using a single Vault cluster. You can carve that up between dev and test, for example, and start to actually really start to apply some heavy policies around that. So obviously, secrets management is one of the key things that I wanted to talk about. And it really does allow you to reduce your attack surface. So that having that single API means that code can be written easier, which then increases productivity. So now your devs teams are being able to write faster and easier and more repeatable code because they have a single API. Now, if we take this to something that I'm going to talk about next, or go into more next, which is certificates and encryption as a service. Obviously, getting and creating a standard certificate from a single API call is a really good thing, because that's a complex thing that developers have to meet and challenge with as it stands today. So being able to leverage that and do it from a single call in your code, again, it helps increase productivity, simplifies the overall code structure, makes it repeatable. And all of those things go to helping reduce cost and reducing your risk, right? You now have no hard-coded passwords. You have them all dynamically created. You have no code sharing. And then just from a management perspective, you pull all that information and your crown jewels into a single point. You create audit and tracking and login from that single point, so you can see what everyone is doing. One of the interesting features with Vault is it's a crypto barrier around the core code. So if you feel that there's been a compromise, you can actually do a break glass scenario and stop Vault, and that will stop issuing any of the secrets and stop any of the application components working. So from a worst case perspective, you could actually stop it if you felt that you had been compromised, which I know is a severe component, but for some customers we've seen it where risk completely outweighs the cost of stopping the application. And so we've talked about the secrets management component. Obviously, another really important part of the ISV and the software SaaS component is how you manage your data, how you manage your customers' data. How do you get that across, and how do you actually interact and save that? And so Vault can act as as I said, as a CA, and it will issue a certificate completely from an individual, from an intermediate CA that's you issue to it. So in one API call, you then have a complete certificate that allows you to then encrypt that data flow. And where this becomes really useful is when we talk about something as a transit app or encryption as a service. And what that does is, what that means is you can actually, from an application call through using Vault, encrypt that actual unique piece of data and actually drive that and store it on the database. So regardless of what the database overall encryption is, and even if that database is compromised somehow, then the individual records within those fields are then actually encrypted. So you've really applied a belt and braces mechanism. And this also means that, as Michael talked about, how do you build through those 4 tiers of the tenancy model? How, does this mean that because the data is encrypted, can you put that data onto the same database, right? Does that now mean that you can actually lower your operational costs because you can actually get data or shared information across your database, and thinking around how you can use this as a mechanism to lower your overall consumption cost and drive efficiency, which then allows you to scale, right? So let's just take a quick look at what it looks like. For those that want to learn more as well, if you go to our learn.hashicorp page, there are all learning tracks around all of our products. And so, this is a good resource that we promote and is very heavily supported. So this is our little app. It's not overly impressive, but we have a few records. And as you can see, if you look in the raw database view, you can just see that if anyone compromised this, obviously they would actually get all of that data. Now, in our, where's our database view? There we go. In our database view, you can see that we're actually starting to create some unique usernames and passwords. So that username and password is that dynamic secret that I was talking about. So this application is now working through grabbing those unique credentials out of Vault, running it into its API call, and making that API call out to the MariaDB database. And so it's using that and writing it uniquely using these records. So if we just add a record here, and I will just do some silly data. There is no data checking on this. Oops. I am seriously underpaid. And we add that record in. So now from our application view, you can see that we've added it in. You can see how dramatically underpaid I am compared with everybody else. But if we look at our database view, you can see that Vault has created unique records for each one of those components. And so we have a mechanism to be able to call it by. We have a table element that we could look up. But the actual individual data and the important parts have all individually been encrypted. And so by being able to do this, obviously now, as I was saying, you really have that ability to take advantage of sharing data across a particular a single database and building out different levels of infrastructure. Whether that's for performance, whether it's just an added layer of security, obviously that is up to individual design and requirements. And so that covers off kind of the how do I build, how do I connect, and now how do I build and how do I secure? And now we kind of get into the last component, which is how do we kind of connect it? And so if you think about, we've built our application and we're starting to think about how we can build that application across multiple regions. How do I know and find and discover what those applications build? If I'm building in a new microservices world, how do I tie those together? Particularly if I want to be able to tie those into external elements. So if our first step, as we know, many ISVs are still have built on-premise components. How do I link that legacy or those legacy environments into my new cloud environment that I'm building and want to scale out? This is an important part of my core business, but I want to take advantage of those cloud platforms. And so what the service registry does is allows us to have a single point of truth regardless of where it is. And Consul runs as that registration point. And then using a Consul agent, it can actually discover and push services as they're stood up and report those back into Consul. So you can register services manually, which is where we can tie in things such as a mainframe or an OpenShift cluster, or even just a managed DB, for example. So blob storage, you can register that as an external service. All of those services can come into Consul, and they will automatically, or it will know and register those services. And then the Consul agent is the mechanism that actually, from the pod or whatever the element application, pushes up with that request, comes back, and now you have an ability to find that. Now, if you add on top of that the service mesh component, what we've been talking about has been controlling functionally the data plane component. Now, if we look at engage in a service mesh, which allows for mutual TLS between those proxy points, as indicated on the diagram. That allows us to actually create an end-to-end encrypted tunnel that allows us to communicate between those two parts of the application. So in this case, we have a dashboard and we have a counting app, and those two elements are built across different environments, and we have connected them together using our service mesh, and now the app can find out the counting data. And so if you think about this from that scenario that I talked about earlier in terms of how do I take my SaaS application that I've built in one particular region and move that into other regions without having to lose that full data set, for example, or how do I at least get a user front end closer so it's faster responses for a better customer experience, but the back end component and data is still kept in our cold data center. You can start to see how you can actually tie these elements together using Consul and build out for those types of scenarios and add value. And so Consul has been designed to fit across all of the clouds, both private, public, but also, it will also run in pretty much any environment. I've seen it being run on Raspberry Pis for an IoT application. So you really have an extensible environment that built around the networking cluster and that connectivity model. You now have a way to be able to join and combine your apps. So obviously, one of our core tenets is being able to build anywhere. So, we've seen a big push around working with Kubernetes, but also being able to tie into other elements, Docker, any of those components that modern applications are being built around, and being able to still support some of the old stuff, so mainframes and VMware clusters and OpenShift and any environment. It's a very flexible platform. And it also integrates natively in with our Nomad, which is our deployment and scheduler. So being able to take advantage of the service mesh to then actually schedule workloads with Nomad down across the platform that you've built, secured, and connected. And so just taking a quick look at what Consul is under the hood. So you have those two parts. You have the control plane function, which is an N+2 node cluster. So in this, a 3, 5, or 7 node cluster. You can integrate Vault into it to do the secrets management component, and then across into the actual pods or deployments, you then either have an agent or Consul templates, which is another mechanism for an app to be able to consume and understand how to talk to Consul. And then those are all of feature around the service discovery component and service registration. And then on the data plane side, we have that service mesh mechanism that allows us now to do between application point and application point. And we've also just introduced a new mesh gateway feature, which allows us to actually federate across different clouds using a single port now. So the federation has become a lot easier to actually build across multiple clouds, multiple regions, and to be able to set up those environments so that you can build the control plane cluster servers in each one of your DCs to be able to give you that local span of control, and then actually create a link scenario across those environments. So that's it from me, and hopefully, there's some really interesting topics in there that either one component or multiple components have pricked interest. From now, I suppose we're opening it up to Q&A and see if there are any questions.
Yeah, thanks, Dave. Thanks for that great presentation, Dave and Michael. Very clear, and it all ran very smoothly. So I'm just checking to see if there are any questions in the tab, and I can't see any at the moment. So, folks, if you do have any questions, now's your time, and you can pop them into the Q&A. Alternatively, I can send you the link to the recording, and you'll have the emails to ask the questions. But we'll just give it a couple of minutes and see if anyone would like to add a question.
So while we're waiting, Michael, just a quick question for you. In terms of, obviously, the elephant in the room, there are native features that Terraform shall we say, replace as opposed to compete. What's some of your, what's some of your thinking around the why? Why would you use potentially Terraform over Cloud Native, or where would you use Cloud Native as opposed to Terraform? I think it's probably an interesting topic to talk about whilst we and maybe stimulate some of the questioning.
Yeah, perfect. Thanks for the tough question. So I suppose I speak to a lot of ISVs who kind of have multi-cloud deployments or are deploying obviously applications in the cloud. And kind of my advice to them is, if you're currently using Terraform and you want to deploy to Azure, there's no reason to move away from Terraform. You know, it's built on top of Azure's Go SDK, so it's all compatible with Azure. So that's kind of what I still customers down from that perspective. If you're new to Azure or new to the cloud and you haven't picked kind of an infrastructure as code solution, I tend to get customers to check out the native stuff in Azure, so Azure Resource Manager templates. Try them out first. If they do not like those for various reasons, it might be unreadable. There's some stuff you can do in, say, Terraform you can't do in templates. Then I suggest you go and have a look at Terraform. So that's kind of the decision points I have with customers around when to go native and when to go Terraform at a very high level.
Cool, thank you. There's a question, so let me just just read this because it's a long way away. So the question is can Consul and Vault act as a facade to existing native cloud provider configurations such as secrets management mechanisms? Yes. So there's an interesting feature. So Vault has an auto unseal mechanism. So the way I spoke about it a little bit with Vault having the break glass capability. To get that capability, what we do is when you initialize Vault, it actually creates a sharded login, which you need those 3 out of 5 or 3 out of n out of a number to actually unlock and start interoperating with Vault. You can obviously storing those manually becomes or can become troublesome if you need to reboot a box in the middle of the night. Who 3 people had them? Where did I store them? So what we've done is actually integrate in with something like Azure Vault and the key management component to actually allow you to put those shards in there and then auto retrieve it. So we're seeing a lot of environments where we're starting to co-interoperate with cloud native mechanisms to allow a single front end across them, and to also just to add value. So, you know, Vault has the only place that we kind of, and Michael and I have talked about this a little bit actually, you know, where Vault does cross is, you know, there is for a very simple key pair management, then that there is, you know, there is a true overlap there, and you go, well, why? However, as you then start to pull that apart to start trying to look at doing either dynamic secrets or using encryption as a service, or starting to put in some of the other functionality around how do I do, you know, role-based control around the API call? How do I integrate in with leveraging my SSH? How do I create SSH keys? You start to build a real value proposition around that front end of HashiCorp Vault, whilst leveraging the power of infrastructure that you don't want to have on premise, and being able to leverage the cloud to provide that as a mechanism to then to build that API front end. So it's a long-winded answer, but fundamentally, yes, you can, and there are mechanisms that incorporate part of the cloud's native features that you leverage to then take advantage of that. I think is probably the most concise way.
All right, thanks, Dave. If there's no more questions, we might close it out soon, give people an early mark. But yeah, if you do have any other questions, you've got Dave's email right there on the screen, dr@hashicorp.com. Yeah, and reach out to him once we finish up today. So Dave, Michael, are you good to finish up?
Yes.
Okay.
I'd just like to say thank you for Michael for coming on and speaking, and I really appreciate you working with us around this. Thank you.
Yeah, and thank you, David, for inviting me. Had a blast, so thank you very much.
Yeah, likewise. Thank you both. Great presentation and demo. So folks, thanks again to everyone who attended. It brings us to the end of our session today. We hope you found it useful. And as I mentioned at the top of the call, this webinar was recorded and we'll be posting it on our website soon. We'll also send you out a link to that recording so you can watch it again at your leisure. And as Dave mentioned earlier in the call, if you want to learn more about our solutions or that you heard today, I encourage you to check out our Learn pages on our website. And you can find that at learn.hashicorp.com. And that's about it. So yeah, thanks again for joining. A big thank you again to our presenters, and hope to see you all on the next webinar. Until then, take care and bye for now.